Okay, this is the related samples t-test. Remember to download the code, to download the file so that you can follow along. So what I'm going to do is go ahead and show you the code. So here is our studio. And again, just as a reminder, this is for related samples t-test. You'll want to make sure that you have these three libraries, tidyverse, LSR, and psych in already, those packages already installed so that you can access them. And you'll want to make sure to go ahead and change this to your working directory. So just as the setup, also notice that one other thing that I've done is I've made this set this echo equal to false. So here, we're going to automatically, unless we tell or otherwise, don't show us what's in this code, in these code chunks. So it's not going to spit out the code. It's just going to spit out the output of the code, which will make things just look a little bit cleaner. But you can always go in and change that if you wanted to, either here or somewhere else, and I'll show you how to do that. Okay, so let's think about our example question. So here, I simulated some data to represent researchers being interested in whether performance on a video game increased as a function of practice. So imagine that they had participants play this video game where they had to search for like food in a complicated landscape. And when they found this food, they scored some points for it by like clicking on it or something, okay? And so here they get a score. There's up to 100 pieces of food that they can find. They get a score from 0 where they didn't find any to 100 where they found all the food. And so better scores or better performance on this example. After they played the first time, they were allowed to practice for about 30 minutes, okay? And so we picked they played the game first, we got their score, they practiced for half hour, then they played the game the second time. And after they play the second time, we also record the same person's score. So this is going to be a related samples t-test if we want to see if scores have differed from pre-test or from pre-practice to post-practice. So I'm a participant, I play the game twice, so I'm in all the conditions, and my score is related to my own score before and after the practice. Okay, so that's related samples t-test. So first thing we're going to do is we're going to load in some data, and we need our data to be in two forms. Okay, there's a wide form and a long form. We've talked about these briefly, but we're gonna, most things are formatted in this. And actually, let me just clear this stuff here, and we'll run this again. Oops. I want to show you all of that quite yet. Okay, so here's our data. Let's read in our data. And then let's actually just go ahead and see what that data looks like. This is in the long form or the wide form. So we're going to type in data. And what you see here is that each participant, 250 of them, have a score for time 1 and a score for time 2. And that's fine. But we also need this, we also need to like say whether these scores are related to time 1 or time 2. R doesn't know how to just test them against each other. So we're gonna have to make a factor that does that. So we've done this before. We're gonna make a factor called time, and we're gonna use this function called wide to long, and all we'll put in here is we'll say, okay, we'll create this as a variable. I'm gonna call this data.l for data.long form. And we're gonna say, take this variable data and create a variable called time, and then it knows to just match rows. Okay, so let's go ahead and do that, and we'll just see what that looks like real quick. And so now if I come down here, and I say, show me what data long looks like. Notice now that I have participant and then I have a particular score and a particular time. And it knows that this participant is the thing to match it. Okay, so we just have to be able to have both of those kind of data here. Okay, and we call this second one the long form because instead of having 250 observations that have one score and then a second, it has 500 observations that have an ID, a time variable, and then the score. So just that helps to remember that. Okay, so the first thing that we want to do is we want to see whether or not our data is distributed normally. And we're going to do this on the wide form because it's already in a format that's easy to access. Here we can say, well, show us a histogram, look inside data, and just show us score one. And remember, for the wide form, we have participant, time one, time two. So we can say data, look inside just at this variable, just at this variable. Okay. So let's do that. So we're just going to look at time one and look at the Shapiro test. And if we do that, our Shapiro test is greater than 0.05. So that's good. Let me just show you the histogram. I didn't show you. There's the histogram. That looks pretty good. And we can do the same thing for score two. Looking pretty normal to me. But let's see with the Shapiro test, also greater than 0.05. So we are good to go with our test. We can keep on keeping on. Okay, so here we're going to run the test. And very similar to an independent samples t-test, we have pretty much the same variables. Okay, so here what we're going to do is, or the same inputs into the function. So we have this function called paired samples t-test, just like we had independent samples t-test. Our formula, remember, is dv squiggly line iv. Same thing here. And here we want to know, does the score vary as a function of the time variable? So note that we only have a time variable in the long format. So we have to use the long format here. So notice that the next thing I do is say, okay, well, the data is the data.l for the long format. The ID is the ID variable. How do I know which person belongs or which variable belongs to which other variable? So how do I match T1 and T2? Well, I do that using the ID variable as the matcher. And we can make this one or two-sided, and we can change our alpha value if we wanted to. So let's go ahead and remember again that I'm calling this results and saving that as a variable so that when I go to my written results, I can just use these values and tell R what to stick in there so that we don't have to change this every single time. Okay, so Control Enter, and then let's take a look. We have a paired samples t-test. Here's our results. We have our DV, our IV, our within variable is another way to say this, our within variable. And then we have our time one, time two, means and standard deviations here. The difference is simply telling us the change between time one and time two, or time one minus time two. So if it's negative, that means that our difference has gone up. Does that make sense? Our null and our null and our alternative hypothesis, and then our T, our degrees of freedom, and our p-value. So again, this is our T obtained, and we're going to hypothetically compare that to a critical value that would be in a table. In this case, the table is in the computer. So here, this 0.001 is definitely less than 0.05. So we have a significant result, and we have an estimate of how big that result is in standard deviation units with Cohen's d at 1.6, so big fact. So we want to describe that to our reader. So here's some written results. So we might say a repeated measures t-test was used to determine blah, 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 blah. And then we're going to use the same formatting that we have in other places where we have the single hash R to tell it that it's going to be R code next, some kind of code in here, and then another little hash to make sure that it knows stop thinking this is code. And then we're just going to call the different pieces of results. Remember that what I mean by pieces of results is that in our result file, we can access all of these different things. Let's show this just quickly here, where, so maybe we would do this in down here, and we might say, okay, results, and then $sign. And now notice for each one of these are the parts that you can access with this $sign. Okay, so I might say, well, what's the t statistic? Great, let's print it out. It's 26.612. Okay, so you can use this kind of formatting to translate between numbers and words. And again, I want to do that simply because then when you go back and you have different data, you don't have to go type in all of these numbers again. You can just use the R code to do all of that for you. Again, I've used this round command that says round some data to some number of decimals. Okay, so you should be able to follow these here. I don't think that there's anything too different. Again, numbers inside brackets mean access this particular one. Okay, so here, for example, this says, show me the standard deviation in italics, then round the results, the standard deviation in the results for the second value to 2 decimal places. Okay, so you want to go back through here and just make sure that you understand how those things are getting into all of those places. The other thing we want to do is we want to create a figure. Okay, so we've done this in the last version, but again, we need to create some kind of data frame that we can plot. And because we have more than one thing to plot, we're going to need to combine a few things using this C command for. Okay, so the first thing I'm going to do is I'm going to calculate standard errors of the mean up here for each one, time 1 and time 2. Then I'm going to say, well, I don't want T1 and T2 as the name of my groups. I'll just put pre and post. If I want to use, you can put anything in there that you want. And then I'm going to tie the first result to pre, the second mean to post using the 1 and the 2, and do the same thing with the standard errors of the mean, which I've just calculated up here. So now I have what's on my x-axis, what's on my y-axis, and what my error bars are, standard error of the mean always. And now I'm going to plot. So I'm going to use ggplot again, and I'm going to say put this whole thing inside of the plot. And then I'm going to say my x-axis is group, my y-axis is the mean. This means bars, this means color. And then in my error bars, I'm going to say for the same thing, my x-axis is the group. My y, for the minimum, it's the mean minus the standard deviation, or standard error of the mean, sorry. Why? Because the standard error of the mean, that's going to give us that piece. And then positive, this piece. And this width just tells us how fat it is. And again, this bottom piece all down here is to make this look sort of pretty in APA. Make the background blank, make the borders blank, take out the grid lines, and make the axes black instead of what they were originally. And if you want to change the size of the graph. So let's see what that looks like. Also remember that we have a figure 1 up here and a note at the bottom just to make it look nice. So here you'll see a pretty close to APA style graph. You could also flip those if you wanted to and all kinds of other stuff. So let's knit the document so we can see what it looks like all together. And now what we will see here is that we have our example, our background in question, but now we just have the output. So here's our histogram, here's the normality test, the histogram of the other variable, the normality test, the results of the t-test without seeing any of the code for this, and then the written results and example figure down here. And again, just notice that we have italics, we have numbers in these places that correspond to those same numbers in the example or in the actual code, as you can see here. Okay, same thing with these, we just can't see those exactly. So this concludes the related samples t-test explanation. Take a look and see if there's any similarities or differences between the independent and the related samples. Most of those you'll notice are simply in the setup of the data. The coding looks very much the same. So thanks for watching and see ya later.